Welcome back to the course on Compiler Design Lab. In this lab, we will be discussing how to convert an NFA to a DFA. So consider this NFA. Here you have state Q0. You give the input symbols A, it will move to Q1 and it will move to itself. If you give B, Q0 will move to itself. And to Q1, when you give a B, it moves to Q2. So this is the transition table for this particular transition diagram. So in order to implement this program, what you have to do is you have to input the total number of states. So you'll ask how many states are there. I'll say there are 3 states. What are the states? States are 1, 2 and 3. Then what are the input symbols? Input symbols, I have 2 input symbols, which is A and B. Then what is the initial state? Initial state, I will say it is Q0. What is the final state? I will say it is Q2. Now we have to enter this transition table for this particular transition diagram into the your program or your input structure. Okay, it can be entered into a input structure or into a file. So this is your NFA transition table. From this NFA transition table, you have to construct a DFA transition table. Okay, when you give the inputs A and B, what will happen? Okay, so in order to construct that, initially I will create a structure for DFA. That structure contains a list of nodes. Okay, in that list of nodes, I will initialize it with the initial state, which is Q0. Okay, and find the transitions for this particular state Q0. So I will for the transition table, this is my initial state Q0. I will find out what are the transitions for the states A and B for the input symbols A and B. So Q0, when I give an A, what happens? It moves to Q0 and it also moves to Q1. So I will write Q0 and Q1 here. Then when I give a B to Q0, what happens? It moves to Q0 itself. Okay. So when you see the transition, you can see that there is a new state Q0, Q1. So you will check this list of nodes to see whether Q0, Q1 is present. Q0, Q1 is not present, so you will add this Q0, Q1 node to your list of nodes. Okay, and you will check whether all the previous nodes have been parsed. So when you will check that, you will see that Q0 is already parsed. That is, you have seen the input symbols to Q0. So you will move to the next input state, which is Q0, Q1. So you will enter that into the transition tables. Now we will see what happens when we give an A to Q0, Q1. When you give an A to Q0, it will move to Q0 and Q1. What happens when you give an A to Q1? Nothing happens. Okay. So this state is already present here. What happens when you give a B to Q0, Q1? When you give a B to Q0, it moves to Q0 itself. When you give a B to Q1, what happens? It moves to Q2. Okay, so you can see that a new state is created which is not in this particular list. So you will add Q0, Q2 into your list. Okay, now you will check whether the previous states have been passed. So Q0, Q1 is also passed with the input symbols. So you have the state Q0, Q2. So you will enter that into the transition table. Into Q0, Q2, you give an A. When you give an A to Q0, Q2, it moves to Q0, Q1. And when you give a A to Q2, nothing happens. And when you give a B to Q0, what happens? It moves to Q0 itself, and B to Q2, nothing happens. So then now you will check whether any new states are formed. No new states are not formed. So this is the final DFA transition table.